Dissertation of Arts and Science, Soldani, will be presented for examination for the degree of Doctor of Science. Professor Tapani Ristanimi from Tampere University of Technology and Associate Professor Andrea Abrado from Università degli Studi di Siena in Italy will act as the official opponents. As the official custos appointed by the Department of Electrical and Communications Engineering at Helsinki University of Technology, I declare this defense open. And please switch off the ringing tone in your mobile phones.
Here I have reported some of the mistakes I found by reading the thesis for the last time for this examination. Right. Right now, to introduce the work that has been done, or what the thesis is about, I prepared a few slides for about some kind of 20-minute talk. And so I would like first to introduce some basics so that everybody is can see what has been done, some terms, terminology, and which will be used then around the talk. Try to discuss the why in general this work was needed, so a general motivation and the problem definition. Then I will explain more in detail what the problem is, so what new problems the thesis aims to resolve. And then I go through the original contributions, which means in practice to explain the corresponding mapping from the problems to the solution. And I will close the talk with mentioning who are the main customer of this work. So the title of the thesis is Quality Service Management in UMTS Network, actual radio access network. So we have the term point of service. Point of service is a term, or QoS, an abbreviation widely used. So if you go through the internet or in the standardization, you have a general definition. So this is taken from the standardization. So the people there specify how the network should be designed. So this is a sketch of the UMTS network. So how they define the quality of service? So we have quality and we have service. Service is also it may mean several things, but in particular case we could concentrate on, you have your telephone with several service applications, and then you try to make a connection. In this particular case you have an ongoing video call. So that's the service. So quality of service, the term relates to the quality of a requested service, in this case video call, as perceived by the user of the service. So if I'm making the call, I am the one who perceives the service I'm getting using this particular service application. So that's the network we're going through now. We have sort of complex, so you might be familiar mostly with the terminal. It's called user equipment. And then you have the radio access network with several base stations that are radiating the signal. So through the air interface or radio interface. And then the signal is channelized and transported to the service application where this particular service originates. Could be, for example, internet. So you have access network, and the thesis mostly focuses in the radio access network, so the management of the quality service in the radio access network. Then, of course, to move the signal from the radio access to the external packet data network would be the internet. You need another infrastructure, which is called core network. In the particular case, it is a packet core network, where the quality service is defined. Right, so that is the generic definition, which doesn't say much, because when you then in practice, you want to design a network to do something, you have two problems to consider. In the one hand, you have what you need to implement in the network elements. In the other hand, you have what really the user perceives. So let's consider first what you have in the network. So what in the thesis is defined as quality of service is what you design, what are the functions, algorithm, mechanisms that there are in the network element. So that means in the terminal, in the base station, in this radio controller for the cellular base station, and the core network. So I can read here, so it's therefore, it's the ability of the network, quality of service, the ability of the network, terminal, and the other network elements to provide such a service with an assured service level. So when the communication is established, you have a logical pipe going through all this journey, and the logical pipe is defined by a set of parameters, which nothing else define how good the service has to be. So that is what we have to assure. So there are functions implemented in the different network elements to assure the provision. Provision means like when you make a reserve for something. So you make space, you make room to offer this particular service application, in this case a video call, in the network to ensure the provision of the negotiated service call between what? So that's just to be an important thing. We have to ensure this along this journey which goes from your mobile down to the point here. We say the ages of the packet core network. We say the public name mobile network. So it's the mobile network which connects to the external world. And we are not then taking into consideration what happens outside the GSM network. So the other aspect, such as QoS, means functions in here. And that's where most of the thesis concentrate. Then you have the other aspect, that is the most relevant. So it's what the user really perceiving. So that term, it's not as quality of experience. So what the user really perceives, it is how satisfying your shares with the service it's using. In terms of what? Usability, accessibility, and ability. So usability means how usable is it? That term is extremely complicated and not successful, right? So that doesn't make people happy. Also, the application is itself implemented, so there are many menus, so that's something that is usability. Accessibility means that I want to try to reach somebody now, really important, I can be blocked with no coverage, so there's no signal. So in the terminal, these bars, they're not there, so that's the thing, accessibility. Retainability means that I want to be in contact with the person I'm communicating with, the service I'm using while I'm moving. So there shouldn't be, basically, connection lost along the journey, or simply the service should be seamless while I'm moving. And then integrity means that, okay, now everything's working, how does the image of the person communicators are fragmented. So that means that should be not there to avoid user satisfied. So the QoE reflects the collective effects, all these effects of the service performance that determines the degree of satisfaction of the end user. So it is extremely complex. So any user has its own standard requirements. But then, what is the main goal of this work then? That's what we have introduced. We deal with the management. Not much. Management means the endable part of the quality of service, not much into the detailed design of what has been implemented in here and here and here, but other than we do something, I mean, the teams propose something in there, but it's mostly to take the maximum advantage when we go and operate the system itself in terms of quality. So quality service management means in practice to break into different facets. So I've mentioned here 4. It covers, you have the service planning, provisioning, monitoring, and performance improvement, or commonly used, especially in the industry, optimization. So management of QS means design of the network, so have tools and design the network to provide such a service the operating network administrator is going to offer. Provision, it means to have some function, some means in the network to ensure that this service is delivered with corresponding compliance with what has been negotiated when the communication is established. Monitoring, that is the most important part in the work, I think, also in general, because also when we have a problem, the first thing they do, they measure our body, right, to see, diagnose the problem. So the monitoring means to go, you have a service ongoing, several communication going across the network, and what we need to do is to measure exactly what is going on there. And then, if you have a problem, we need to do something, possibly proactively. So what we do first, we do from a blood analysis, you say is everything is fine. If you don't have that, then you go more in details. So you enter again in the detailed analysis of the measure you have made in the communication chain. Performance improvement or optimization, this is definitely another important aspect, because when you buy something, you have an investment, what you want to do is simply exploit that as much as possible. So it means you're not going to over-provision or put more things, you know, but even for your car, you try always to take the maximum of it, to optimize it, to find the best configuration to go with the system you are having. So in particular case here, the thesis proposed a genetic approach, which I'm going to say something more. So the point is to have a network, try to change the configuration of the network so that we accommodate as much as possible users at a given service quality, so that not violating what the user is expecting. But why that has been done, this work, in general, we have several open things in the telecommunication world, in particular in the standardization. So if you go through the standard, what the standard says, okay, that's your network, now it's, yeah, it's almost not visible. That's your network, you say, you have to design the network, they say, and what you have to do here, you can only exchange a certain information between the two boxes, and then with a certain parameters. So they define the attributes, the characteristic, how the service should be in there, but they don't say how. So they don't explicitly say, okay, in this box here, you have to put this outcome implemented this particular way. No, they do an architecture, and so boxes, what needs to be exchanged between them, and how this service has to be. So they leave it open, so they know basically to the vendor or academia, everything, for design what this should be in there. Besides, if you check the overall QS management problem, so the 4 points I mentioned before, there's very little material in the literature. So there are a lot of details when you go into the detailed implementation, but then when you try to capture the big picture, all the problems in operative next to the mystery space, there's very little material. And then the problem is that when you try to design now the algorithm, that the standardization, so basically they're not internet, but you need to validate them a priori. So it means that you know just say, yeah, this it does implement it to a certain extent. So we need to check first how it performs. So we need to have tools, means, software to validate first theoretically and then deploy that in the network. Then another thing is service application must be monitored. So this is to ensure that what you agree with the customer when you subscribe for a service is sustained by the network. So you have to measure. And then there are definitely clear needs and methods to improve clear needs for means and method to improve the performance of the services supported by the network or the operator. Okay, here you have more in detail. On the crowded slide, the question, the thesis, new problems. I've just put in terms of question. The thesis tried to provide an answer. So they are in the introduction of the thesis. I'm not going to cover them. And so they are detailed. For example, if I read the first question for the provision is it possible then to provide the best treatment to this best service or use of the same services in Newton according to service specific characteristics and performance requirements? So in other words, you have a certain service portfolio you are going to offer to the public, and then how should design the functions in the network, particularly UTRON. So UTRON is this network elements, only the radio access network. How would you design the algorithm here so that these services are appropriately provided? That's the first question we try to answer. And not only, I mean, there's to be implementable, because it's an easy thing, for example, to go and design an algorithm. I can design the algorithm. Then I go for the implementation, I can't do it, because the measures are not there, because the interface, the standards are not there. So I cannot implement it. So it's also an objective that the algorithm has to be robust, stable, but then implementable, something that can really sell, feasible for the implementation. Planning is, I have a couple of questions here, is what approach to the embedding of physical, okay, this is what approach to model basically the white CDMA system, level simulation, one of a simulator that will make it possible, what kind of simulator will make it possible to implement this function, we're going to implement network elements, and also support service-specific characteristics without, this is a key point, without sharing the complexity of short-term dynamic models. So without to be extremely complex, to go into the details so that any simulation would take days. That's the first challenge. Second challenge is, you might not be interested to go in such details. And it could be like, for example, you have a service package, service portfolio, or for example, a user wants to provide new services, and they want to know simply, now I want to launch POC, what happened to a cell? So you need a tool that provides you a very quick and dirty answer. So how that tool could be done and taken from the simple model you had proposed above. Monitoring. So this monitoring is also an interesting topic. Very, very few little material in the literature. We said the standard says only what to measure, but then when you say how to measure, it's a problem. Everybody wants to measure and knows exactly what to measure. But then when you say how, that's an issue. So what the thesis says, the question would be that how could we make these measures? How? Accessibility and ability measure. Besides, how then we can measure the application services without making drive tests or disclosing at different interfaces the protocol state? Is there any trick to adopt to do it? Optimization is, firstly, I think a network administrator wants to know whether parameters needs to be changed. Because that entails a lot of overhead, costs, operation to do it. So that's the first question. Do we need to change parameters configuration when the input traffic changes the mix? So that's the first question. Second question, if you have to change n parameters simultaneously, not just one, how would you do it? How do we, how the thesis, how I try to answer this question. So for each point now, I'm trying to explain what the thesis does. And they are the original contributions. So this, about the planning, the thesis proposed two simulators. One is for dimensioning a cell, and the second one is for studying thoroughly the quality of services implemented in a network, either for planning the network, like in this case, or simply to analyze the radio resource management function before putting them in the network elements. So we have two tools. The tools, RS, the notice RSC is also used to validate most of the results proposed in the thesis. Then for provisioning, the thesis propose some algorithm, we call it a service differentiation. Particularly we have the mission controller, control package scheduler, and for the scheduler, the thesis propose a robust scaling algorithm for the, now we should go in, here we are in the detail, but it's a fast scheduler that can be designed in the different layers. So it could be in the layer 2 of the communication, the layer 3, different layers, and it enables to serve, if you, let us have a look at this picture here. It enables to serve fairly different users using different services in the network. The fairness could be in terms of throughput bitrate, so that it gets be done, so wherever the user is gets the same bitrate, or in resources. That means we need to reduce the bitrate when the users goes more far, when the channel is more adverse. So the thesis proposes. And the proposed algorithm, they do enable the operator to handle the request to ready resources according to the offered service characteristics and priorities. So the thesis shows how, basically, by implementing such algorithm by means of priority parameters differentiation of the different methodology which are fade throughput versus, you can have some spectral efficiency gain, which means simply that an operator and administrator can serve more users simultaneously at a given service quality. So that's the point, without putting more resource, more base station, more sites. Okay, then about the QS monitoring, what the thesis proposes are measures, so you say for accessibility and ability measures, such as throughput, which means particular type of bitrate, erroneous losses you have on the packets along the journey, transfer delay, so you have a packet coming from elsewhere here, so you see how this packet suffers along the journey, and then some delay variation in the packet, a particular important for certain type of say, classes of traffic like streaming, if you don't have a buffer, or video ports, voice in general, conversational type of traffic. And then we show by a simple, very simple classification of the measures in the radio network controller how network administrators, so network management system, can then associate the correspondence of a set of parameters characterizing the type of traffic across the journey to the particular service application. So we are not basically measuring explicitly each particular application by dumping data in here or putting a particular analyzer in here, or mobile agent in here. No, we just go in here, implement the measure, we classify them, and then based on the characteristic of this pipe, we recognize that, okay, good, this point now is carrying port, and then I'm measuring port now, and vice versa. So that we don't need the complexity and the costs of other implementation solutions. Optimization. So the optimization, the thesis proposed a genetic approach. Genetic algorithms are used widely, so it's not there the point. It's how that has been basically customized to capture the optimization of quality of service and how the fitness, it means how the particular configuration of parameters we are going to implement in the network perform. That is the tricky part. And that was very simple. How to measure it was simply measure, like say, I just check I measure my services, and then I see the one that performs worse. The one that performs worse, I pick it up, and then I compare it to a target threshold. Am I satisfied? In other words, is this user satisfied? Yes, no. If it is not satisfied, then I have to do something. So I make this sort of parameters reproduce in an intelligent manner and provision new configuration up to I'm achieving that all the users are more or less satisfied. So that is the test configuration having been. So then, to conclude, this is the last slide I have. Who would then benefit this work? I mean, firstly, I would like here to highlight the fact that technology is extremely rapid. So there will be soon talks about WiMAX, talks about 3.9G, any kind of things, but that's not the point. So the thesis, at least what I've tried to do is to write some methodology, explain some methodology that can be adopted also while making studies across other different technologies and supporting QoS. So if you have a QoS concept with a particular set of parameters, all the basic idea that the proposing thesis can be more or less applied. And if you have the network, it implements a similar type of protocols. Who will benefit from this work? Vendors such as Nokia, Ericsson, I mean, those these kind of companies are producing the network elements, and then network administrator operators such as Lisa, for example, and then the research community, not only the industry, but also academia, and of course all of us, if the solution would be ultimately implemented. Because we benefit the quality of the services we are currently using in the 3G terminal. So that basically concludes my talk. And now I ask you, Honorary Professor Ristaniemi and Professor Abrardo, appointed as opponents by the Department of Electrical and Communication Engineering, to present the observation that you consider appropriate for this dissertation.
I will give just a very short speech introducing the work of David Soldani. In particular, I will try to stress the importance in the field of mobile communication. Mobile communication, in its origin, was only voice communication for business users, while just 5 years ago, transmitting data by means of mobile system meant little more than transmitting text messages or browsing through a very slow connection. In these days, customers are experiencing, and we are all experiencing, the first very fast user-friendly multimedia services while moving, thanks to the first wave of third-generation UMTS systems, which followed Japan's first release. And by means of third-generation systems, it's now possible, as many of you know, to view news, sport highlights, or music, video streaming, or video streaming in general. Of course, in the next future, a mobile communication landscape will be more complex than today's. However, it is expected that third-generation UMTS system and the evolution of UMTS will maintain a key role for many customers around the world. This will be particularly the case while wireless local area network system or other low mobility or nomadic systems will remain unproven in their ability to generate strong revenues for operators, different services in different manners. So this work aims at proposing proper solution to quality of service management, which broadly exploit the concept of service differentiation, as David has shown in his presentation before. Of course, due to the huge amount of parameters which interact in this field in unpredictable manners, the above issue cannot be studied or can be hardly studied by means of analytical approaches, but they can be studied mainly by means of computer simulations. Hence, the work of David proposes experimental settings, algorithms, and procedures which aim at providing solution, in particular, to the following aspects related to quality of service for third-generation systems, that is quality provisioning, quality monitoring, quality optimization, and service-driven network planning. This concludes my short speech to introduce the work of David, and now I guess we will go more deep.
So, we can start with a couple of general questions and then go more on to details. So, first of all, about this introduction. So the main theme in the thesis is that you have developed simulators by which you can derive results, and in the introduction you start with a rather strong claim that analytical approaches are invaluable, so they have no value.
No, invaluable, extremely important.
Okay, so this is mine.
No, invaluable is invaluable, so extremely important.
Okay. Okay, then you are actually, of course, right.
It's right, English is correct.
Okay.
So invaluable means you cannot estimate the value, it's extremely valuable.
Okay.
I agree, yeah.
Okay. Because I okay, perhaps
Sorry,
I should have
used
used
different
the
words.
translator.
People usually complain I'm using strange words. Yeah.
Well,
But it means really, I can check now. Invaluable is of any value,
okay.
not measurable, the value they have. That is the full translation.
Okay.
Okay.
So, then about the prior work which is done in the field, you have done this research, what has been done previously, and I was a little bit surprised that there were quite few journal articles in the list of references. So, is it so that the topics which you cover in the thesis, they are not that much recognized by international journals?
I mean, the journal I found, some of those are simply disregarded, and the reason I made twice this search in the literature. I made it when I was trying to publish it. Of course, we studying, you do this, and then it was also the examiner asking me again to go through, and then I redo it extensively using this. I went into the papers I found is the one I reported in there. What selection I made is was mainly watching the feasibility aspect. So there have been several journals, even by Viterbi and so on, people working on the differentiation or algorithm like Wig-Fescue. So either the algorithm was implementable in routers, so you play with the packet, not with the bearer server. So what we do implement here are bearer server. So the schedule is not packet schedule, it's a schedule of transport channels. So you schedule bit trace, don't schedule packet. So that was one selection. And the other one, most of the algorithm, they're really, from the implementation point of view, unfeasible. So they require measures, they're not there. Like you would need to measure the RTP level, say it's not there. And for example, also when I proposed in the scheduler the possibility of slightly improve the probability of being selected, the user standing, I was thinking let's just measure speed rate, right? So we measure the bit rate, we compare to the target, and then we can improve the priority if the user doesn't get a satisfactory bit rate compared to the target level. But then you have a problem, the challenge is that how you're going to implement it. If you measure the mark layer, if you make the measure at the mark layer is fine. So it reports it, you measure the buffers. You measure the bit rate, you have to measure RLC layers and a problem in implementation. It increases the degree of complexity of the solution, which may or not may justify all of it. But definitely when I went through the literature, the work I found was not particularly relevant for the one relevant found I put in here, and just to review it, I didn't criticize the work extensively. So I adopt more. So just to review it, say this is the work done, but definitely what the thesis proposes is an alternative solution which can be in practice implemented in real products. What does that mean? It's not no particular solution, but it could be like it makes use of measures that are available across the interfaces. Okay. So
Well,
that's more or less the work out.
So could one of the reasons be that perhaps you concentrated too much on the future FED, or did you search for the? I mean, there are topics like quality of service in general and radio research management.
I have investigated for the differentiation of BERS, in particular using the D.Sc ages, and then I leave the research to the one I got to publish through. You know, if I go now into the internet, I found now publication, but this work I published in 2003. So if you check the publication, and then when I went through again, I say, okay, I will arrive up to 2004, but I already published this before then. So would that make sense now? I mean, putting here work, which is, I mean, more, of course, it's more new, and the things are good. So that is also an approach I've used when I was investigating in the papers.
Yeah, I mean, from the academic point of view, that's of great importance to explore the whole area deeply,
Yes.
so that you can accurately specify where is your work in the
Yeah, I have a right to this, not the publication, the one available like now in Explore, so you get 2005 are in there. Basically. On the other hand, I didn't go into the HSDPA problem because the differentiation is not much now. So I've seen now following the argument for differentiation we're speaking about, whereas in HSDPA now coming. So and in this thesis is proposed as future studies. So not scheduling in general, but really focusing in a particular case of differentiation, QS intended as differentiation.
Okay, one more question from the introduction is that here for the first time you introduced this kind of thing like quality of service distribution monitoring. So considering your work, would you consider this work to suit better to the quality of end-of-end quality of service business or quality of service measurement, distribution monitoring? So are there any differences between those two concepts?
I didn't capture the two concepts. So one concept would be the end-to-end monitoring, and the other one, or is the statistical sample.
Yeah, and then another is quality of service distribution monitoring.
So distribution monitoring means that I have a population statistical
Well,
monitoring.
that's what I'm asking, since you mention it here. So what do you mean by it? It's on the page A. Quality of service distribution. Second paragraph.
You see in the review. On the second is section 1.25.
Yeah, just on top of that.
So it's still in the review.
Yeah, in the review.
We wanted some insight into the QS performance monitor here. You mean here? Some insight. Okay, this is in 38. The challenge involved in providing QS distribution monitoring were discussed. So still a review of 38.
Okay. So how this distribution monitoring is different from end-to-end?
Let me see the paper, because I think that's a nice paper which has own definitions which do not reflect. If it is the one I have in my mind now, 38. Yeah, here, yes, here is, yeah, now I remember, this paper says, so and what is written, the definition that this paper has are two. One is end-to-end, so our measures available only at a server and at a terminal. and the statistical monitoring are in the network elements. The thesis covers statistical monitoring solutions. So that's
So the basic difference is that in quality of service distribution monitoring, you can actually try to identify what portions of the network
right.
are in the lousy conditions, not just the end-to-end.
So what the thesis does is the measures are environmental control. So internal and end-to-end. It's just applies to Utah.
Okay.
And all this research I revised, especially the D.Sc, they are for measuring the steering drive tests.
Okay, that's for the introduction. In the second chapter, you go through the overview of UMTS, and that's okay. Let's go to the chapter 3. So now, beginning to ask some detailed questions about models and assumptions which are related to that. So in section 3.4, you describe the environment models.
Yeah.
Okay. And you introduce this Okumura-Hata model for the first time.
Yeah.
So, since you now don't have a reference here, could you briefly explain what we usually understand by Okumura-Hata model?
Well, yeah, it's a model which has some limitations. I think the antenna should be, but it's a widely used model, at least when we do network planning. Not in the detail, so I think we are not requesting something like measures or. So it's a model which captures well the the local mean of the field strength for a certain distance away from the base station. It's not too close to the base station, and the height of the base station should be rather above a certain limit. So, but in this particular case, that's not the point. So, in this particular case, I think the model was important and tuned with measures made, and then you tune these correction factors. Right, but I think the key point was it's not really important to have the absolute numbers. So in that particular place to have that particular level, that's not the point. Here is the issue of the differentiators. It's a relative impact of the performance when you use the tool.
So what is actually, what parameters you need for this model? What does it tell? The parameters you need so that you can apply this Okumura-Hata model?
You need there are correction factors more for TOEFL. You need a map. You need now let me think about the formula. I haven't seen the formula now since I was doing model tuning. So you have a formula which includes the so there are the line of sight and line of sight contributions. It's a simple free formula. You can derive by hand using free formula. Plus there are corrections because it takes into account the morphology and topology of the network. So and then we usually tune it. So you import in the tool. They have this formula with this C1, C2, Cn, which apply to different. You need a map. Basically, you need a raster information only, no vectors. They have both Shikigami. So in this particular case, just a raster information, morpho and top information. And then in the formula, longitude and longipixel, all you have to tune to C1, C2, these correction factors by simply fitting the local mean with standard deviation, what you measure with the one is predicted. So what you do in practice is take away the line of sight, you import the roots, and you make it possible that they do match.
Okay.
So that's a very simple formula. Extremely useful thing.
Okay.
At least particular for these studies. If you then want to make an analysis like you want to know what happened indoor, or you want to know what happened very close to the base station, you want to know Then you need other models up to the this ray tracing model. So it depends on the particular studies you are going to make. But in this work, what really matter was the difference to the impact. So it would be questionable if you have like really different services, the model would apply differently.
So this accumulator, it mainly gives the propagation loss.
Yes, balances in
So
average.
what about shadow fading? Have you taken that into account?
Yes, it's a composite, it is a composite model, in fact, what we have imported from another tool, which includes also the contribution of shadow. So in this simulation, we imported from another tool.
Effect of multiple fading, right? You do not
There in
consider,
the, you know,
yes, you do not consider the effect of multiple
there's
fading.
no multiple fading
Okay.
model. Yes.
So you mean, you say that you just consider it in the fading margin, because you have, I guess you have power control, the margin to compensate for fluctuation. of
Fast fading margin.
Okay, you consider that. But in this case,
Well, okay. Then we can
I think that in general, multiple fading margin can take into consideration multiple fading for what regard the intracell interference, but extracell interference cannot be taken into consideration by means of fading margin. That is, how did you compute the fading margin?
the fading margin is parameters. We usually do have it in the
You have some
Yeah,
like
function.
table with 100 kilometer per hour, 3 dB or something like that.
It was in this, I think in here we had I had in this EBNO requirements as described in here. So fitting margin is, you have a margin if you make like leak budget. So you have a leak budget, so it means that you make an Excel file in your calculations. So you take the margin or for fitting, particularly what you put the margins to the scheduling, so to let the power control work. But then when this other meter, it goes into the system, and then as a matter of fact, the PNGB is different. Because you have the old one, you have the one you have the meter. So it's keep on going. Did I answer your question? So we need to predict it, scheduler predicts it, and then if you have a bit of different zero, it goes to power control.
when you perform scheduling, you must be aware of the power, the load of the set.
Yes, you do.
And the load is evaluated on the basis of
On the
previous
previous measures.
measures.
Yes.
That means that maybe you consider maybe that the system is synchronous. Everything happened in the same time. Maybe
The system,
if we are two different cells,
the power control system function. Schedule is done cell by cell.
yes, if we have two different cells, we interact, we generate the interference, okay?
Yes,
But we change, we perform scheduling together.
yes.
So okay.
You notice afterwards, because I'm on myself, that there is
So
another cell.
did you, of course, maybe in this case you have, as you told before, a warm-up time.
You have a
before-
warm-up time,
okay.
yes. And now it's not visible here,
Okay.
it's in the statistical confidence of the data. I've analyzed the
Yes, this is
impact.
one of the problems of cellular system where you want to simulate something and you have synchronism.
Yes.
You have that thing change altogether and finally you have convergence.
Yes, it
Okay.
converges. That is shown on page appendix 190.
Okay, the warm-up time, yes.
Okay. Couple more questions about this ARES. So that the mobility effects can be taken into account, for example, by speed dependent EV0.
Also,
Okay.
So what we do here, if you have bulk, like it was, task performer was 0, and then 8 or put 16, it's just no chance for bitrate.
Why it's not possible to use different transport form?
You can, yes, but usually when you provision it in HLR, and in HLR you have to set the speed rate. You could do it, especially for stream, but then streaming also. The challenge is that you have a streaming service, with a source bit rate 6 kilobit per second. So to give less bit rate doesn't make sense.
No.
You see, if you give more bit rate doesn't make sense either. Say you're limited just performer. But that doesn't mean that proportion these fair resources it's not more spectral efficient. It is absolutely true, it is, but not for these particular services.
Of course, because why you say that it has no sense to have higher bit rate?
Because the third speed, because you have the systems, you would have a source bit rate, which transmits at 64 kilobits per second.
Okay, but in streaming you can have buffering, so you could have, for example, a period of unlucky channel.
Yes, but that will make sense, like 64, 1 to 8, that's it.
Okay.
So it's still limited in 0. So when you try to accommodate the bit rate suffers. If you watch WAP instead, which takes from 384 down to 0, or many bit rates, it's a more challenge to accommodate users, more users, because the trick here is to accommodate more users, right, at a given user stage. But in this case, that is from the graph results, that's the problem. Do you agree?
The problem is that if you don't have a degree of freedom on the bitrate, you cannot implement fair resource.
So it's not convenient, I would say, to conclude, it's not convenient for real-time applications to offer best effort. It's not convenient. It doesn't provide any, I mean, this effort you would into for the implementation won't go through. I mean, it's difficult to have it. Doesn't justify it. And I think most of the operators, they are not offering pork with neither, they do serve pork and other services on best effort. So source bit rate is that.
In the doctoral thesis of David Soldani entitled Quality of Service Management in UMTS Terrestrial Radio Access FTD Network, the role and importance of some of the key aspects of quality of service planning, provisioning, monitoring and management for future FTD networks was investigated. The topic is quite broad, it is timely selected and an important one among the ongoing research on wireless cellular systems. The thesis is written as a monograph and some of the results have been published earlier in international conference proceedings. The major contributions of the thesis were the following. Firstly, methods and simulation approach for rapid estimation of the number of users of a given set of services a cell can serve with a predefined level of quality. Secondly, the development of a so-called virtual time simulator for the service-driven radio network planning. The proposed approach overcomes some of the limitations and complexity issues of the static and dynamic system simulators and provides an appropriate platform to assess the performance of quality of service management functions before their deployment in real networks. Thirdly, development and evaluation of radio resource management functions with the bearer service differentiation, which gives a possibility for the operator to handle the requested radio resources according to the offered service characteristics and priorities. Fourthly, methods to measure quality of service accessibility, retainability and integrity in the radio network subsystem with a goal to provide means and methods for the operators to monitor service applications. And finally, quality of service related multiple parameter optimization by means of genetic algorithm with a proposed fitness function. The thesis is well organized and reads well. It contains over 100 references indicating that the candidate is well aware of the recent research in the field. The results derived in this thesis were mainly obtained by means of the new proposed simulators. The verification of the simulators was carried out by a comparison of the results got by the proposed one and another one which was well understood and verified too. Also, the statistical confidence of the simulation results was adequately addressed. The doctoral thesis clearly contains new results which are suitable for doctoral dissertation. Part of the scientific content has already been acknowledged by the international scientific community. Clearly, the thesis brings a good scientific contribution to the field. The oral examination confirmed that too. Therefore, as the opponents, we recommend that the thesis is accepted and given a grade pass.
Thank you. Ladies and gentlemen, I ask those of you who have observation to make on the dissertation here presented to kindly request the floor from the custos.
Anyone besides the opponents who intends to make unofficial observation about the dissertation shall give notice of this intention at the defense. Otherwise, that person loses the right to make such an observation. No observations. So, on behalf of Helsinki University of Technology, I thank Professor Tapani Ristaniemi and Associate Professor Andrea Abrado for being opponents in this doctoral disputation. And I declare this examination closed.
So, ladies and gentlemen, I would like to invite you for some refreshments here upstairs. They're served in the front of Auditorium Espoo.